Well, welcome students to my lecture number 35, where I want to show you about another equipment which has been developed particularly for control of weeds and where chemical is used. Well, we have discussed the various aspects of control of weeds, which started from manual control, just manually removing the weeds, to small weeding devices. Then we have also talked of power tiller driven devices, and then we have also talked of the various types of tines which are utilized for cutting and removing the weeds. Then we have discussed a ultrasonic sensor based unit wherein we wanted to control the weeds which are there in the row as well as in intra row. This has been discussed at length now, but then we have done something else which also has made a mark and which has been used all over the world in earlier. We use of herbicides, particularly if you have a selective herbicide which is available, then it is very easy, because in that case then the smothering of the weeds will be very easy and for a longer duration of time. So, you would be in a position to control the weeds quickly, and maybe once or twice itself application will suffice to give you enough time in which the plants will grow and the seeds will not revive. I remind again that we are not talking of eradication of weeds, which is simply impossible. What we talk is control of the weeds. So, we employ different methods. We also talked of the biological method, we also talked of flame and all that. So, in the line of these, particularly when advanced level, we have used image processing to develop this particular equipment. So, let us have a look at what we did. The name itself is microcontroller based variable rate herbicide applicator, because we wanted to check as to how we can vary the rate depending upon our requirement of the infestation which is there in between the rows. So, let us have a look at how the whole system is designed. Well, mechanical weeds, well, if you recall, mechanical weeds, mechanical weed control was that by mechanical devices, as I said earlier, that we have different methods by which we are controlling the weeds. Mechanical is one. Then we go to chemical one, we have talked of biological as well. So, I have put this slide just to remind you, to bring back to the to your memory, that see, in mechanical also we were trying to control the weeds in the rows as well as intra rows. Now, same thing we want to do here. Of course, we will not be controlling the intra row weeds in this case, because we do not have we have not made arrangement for controlling intra row weeds, but definitely we are talking of the inter row weeds. Here there is a chemical system which has been developed, and this system is application. In fact, we are calling this as an applicator, because if you spray the chemical, then very likelihood that it will spray to different locations, as well as it may also fall on the plant. And if it is not a selective herbicide, it will harm the plant as well. So, that is why we are talking of application of that. That means simply applying on, there is a, you can see here that there is a roller here. Now, these are the different rollers. So, on these rollers, then we are wetting these rollers through the chemical, and when this roller moves in between the rows, it will apply the chemical onto the weeds, and within 48 hours these weeds are killed. This has been seen. So, for just to recall your memory, that weed control we are doing these, and chemical weed control here. But very important to understand here is, we are talking of selective herbicides. Non-selective herbicides we would not like to advocate for with this system. Now, what we are doing, how we are doing, we will discuss in detail as we go ahead. What are the components of this chemical herbicide? Well, they are simple. We need to know about what are the components of the control system of the chemical applicator. We know that the power source will be there and then other components will be there, but only here let us see what are the control system which is which is controlling the application part of the chemical. Now, you can see here we are talking of a web camera, we are talking of laptop, we are talking of a program which has to be written to see that the system is able to identify the location where the chemical has to be applied. The microcontroller unit with the relay and components. This is solenoid valve, because this solenoid valve will be energized as and when requirement comes, and there is a power for battery here. And this whole thing is shown in this particular diagram. Field system which has been tested in the field condition, and then we will show you video of that in the later course of this explanation. Visual basic, design assist, in fact, what are the various systems of this control system? In fact, see, what we would like to do is, initially the system takes image capturing. The system will like to take the image of that, then processing of that image, because there will be a requirement of processing of that image, because we would like that image should be differentiating between the plant and the weeds. So, accordingly there has to be image correction, then segmentation of the image, and image morphology. These are the systems which will try to differentiate. Then we will then talk of what is how do we actually understand that this particular one is a weed or not a weed. So, the RGB analysis is the one which is done, and the intensities of all pixels in image are compared depending upon which one is more or which one is less. So, for example, the pixel is marked green, whose green intensity is greater than the red and blue intensity. So, it will be marked green if the green intensity is greater than the red and blue. So, we are talking of red, green and blue. So, this RGB, on the basis of these pixels and on the basis of the level of intensity of this, we can call and identify the conceptual way. Now, using this, a visual basic program was developed in the system, and once it is identified, then the system was instructed through the solenoid valve to apply the chemical. Now, we will show you where it is applying and how, and how do we attempt various variable rates. Well, for making the decisions, of course, inside this is inside this software, because how do we take a decision and all that, this is the part of the software which I mean, just if you go through that you will understand, but then unless you do not know coding, you will not be able to appreciate this part. But then since we have done, we would like to just tell you that there is a threshold method by which we are in a position to identify, and what are the parameters which tells that the level of identification is useful or not. So, one of these is green index calculation. We will find out what is a green index, and then make a decision on the basis of that. So, the ratio of green pixel to the total number of pixels. If you see, as we discussed with the RGB analysis earlier, that we are talking of the intensity of this RGB. So, if the green index is when the ratio of the green pixels to that of the total pixels is a green index. So, if we take green index as itself as a parameter to differentiate, then itself also it will give us some idea as to what is the extent and what is the type of weed that we have. Well, let me tell you that there are many things which have not been answered in this particular experimentation or in this particular device, but then to a great extent we have tried to understand the whole concept of weeds and the plants. Spray amount and the solenoid operation. Well, the spray amount will be calculated. See, we know that what is the amount of spray means application. In fact, here I would not like to call it a spray, we will call this application part. So, the application, in fact, I will not call it spray, I will see the application. Application amount will be calculated from the formula set in the code. Well, definitely we will set a formula depending upon what is the chemical, what is the area required, and what is the rate at which we want to deliver and all that, which is predetermined by the designer. Accordingly, once we have this, the microcontroller will operate the solenoid valve and the liquid is released towards the rollers. So, as I showed you in the diagram that there are rollers. So, these rollers or sponge rollers, you can have different material also, but we had tried different materials and found that the sponge has a longer longevity, at the same time could retain moisture for a longer duration of time. So, it saves on the chemical, because the pores are there, and in those pores if you can maintain a certain level of moisture of that chemical onto the rollers, then we are in a position to maintain or minimize the wastage of this, because if it is fully saturated and the moment it will be coming in contact with the hard ground, it will ooze out and hence we will lose the chemical. So, that we have taken care of. Sensing the motion, actually this system has another thing, because we are also trying to sense the motion in order that what should be the rate at which it should move, so that we are in a position to apply the chemical and the images are being taken, because the system is online. Actually, we are taking the images in the front, and then at the back we are instructing through the microcontroller and through the solenoid system to apply the chemical onto the rollers, and the rollers are behind. So, it is very important that we should have devices which will maintain maintain the speed at which we are trying to move. The signal is provided microcontroller, it means that machine is moving and has moved a set distance. Well, these are the sensing motion of the system which we have understood. Now, these are details. Once you go through the details, you will try to understand. But this has not only this, lot of thought has been given in this for operation, for designing this particular machine. Well, flowchart of this control program. Well, if I put the whole thing that I discussed here into a form of a flowchart, you can see there that there is a start of this proximity pulse counting by microcontroller. So, this it controls the microcontroller, and proximity pulse is controlling how many pulses it has taken, what is the image that it has captured, then the image is being processed, then green index and decision of herbicide application is taken subsequently, as we have given the formula in the code of that. Then the communication with the controller. Now, this information has to be communicated to the controller to make a decision as to whether to apply the chemical or not. So, if it is yes, you can see that decision for if it is yes, then yes, solenoid valve will be operated and switched on and the chemical will be applied. If it is not, then solenoid will be closed, and then otherwise if it is not, then it will go back to the system and try to take the images and go on. This is how the system will go on like this until unless we stop the whole operation. So, this as such, this is a very simple flow chart, a simple program. It takes the images. After the images are taken, then it identifies through the microcontroller. Then microcontroller, after identifying and finding out the intensity of the infestation, it will give information through the solenoid valve, and solenoid valve will get operated and give the chemicals onto the rollers. And the rollers are anyway being just pulled. We have not given any other power source for pulling, because they are just being dragged behind the tractor. So, they will be going in between the rows. They have been made just equal to the width of the rows. So, such that it does not come in contact with the plants, but then it will be in a position to operate only onto the weeds. Well, this is how things will happen actually. You see here that you can see that from all the camera, this has come to the laptop, then it will go to the microcontroller, then it will go to the various solenoids, and then from the solenoids then it will come into the rollers. So, you can see here that it comes to the rollers, and now this is the information. Once it goes to the controller, then the whole information is now taken care of. This is the weed here, this is the weed here, and these are the locations where your camera is there. So, the whole system is dragged, this system is dragged. So, the whole control you can if you see here, we have seen cameras 1, 2, 3, 3 cameras. You can see that 1, 2, 3 camera. In fact, if it is a 6-0 unit, there will be a 6 camera, and like this. Then rollers R1, R2, R3. This representative system has been shown to you here as to how the system is working. Image processing using Visual Studio, yeah. How do we do this image processing using Visual? This is the electronics part of it and the processing of the images, etc. So, since you are not aware so much with this system image processing, I will just like to tell you that try to understand what we want to say here, that we are in a position to grab the images of the of the weeds, and then trying to process with respect to what is the intensity of that, how do we do this thing, and then what information we feed to the microcontroller, and then after that to the solenoid valves and all that, and these solenoid valves, etc. In fact, these are all independent units which need to be read separately, but then these we have combined here only to have. As an engineer, you should be aware that various such systems are developed, and they are working very successfully. In fact, on wider row crops, you will find that they have a better application part. So, if I just go through what is written here, you can just read here that open library was used with the files coded and imported. Then the main software was created with algorithms of detecting green pixels and making corresponding incorporations for decision making for the application. This is in brief which has been said. What I explained to you is in fact here, and the details of the system is shown over here. You can see that this is in the laptop he is trying to see here, and the other systems are say the camera is over here. Now, these are the rollers. You can see only 4 rollers are shown here, and the 2 have been lifted up, just because particularly when you move, you will find that the width is slightly larger. So, we have tried to design a system by which this can be folded and within the same width of the tractor, and it does not look very odd. So, that is why we have done this thing. This only talks of how we have created and used the knowledge of image analysis for designing such a system. Well, you can see here intermediate calculations of green index and herbicide amount in the software. Well, this is this will be of not much use to you, but only a proof that yes, we have in a position to do this and get the green index and the herbicide amount. How do we do this thing? What we have written in the software, what is the formula that we have used here, those are things. And now, since this is a intellectual property matter, that is why we may not be in a position to tell you all details, but then as an engineer you should know that yeah, this is possible, and then by going through all details you could be definitely in a position to design a new one or something better than this, like that. So, we just wanted to show you the intermediate calculations for green index and what should be the corresponding herbicide amount through the software. This decision has to be taken. before you instruct these solenoid valves for application, and ultimately it will fall in the rollers, and since the rollers are being pulled in between the rows, they will smear and the chemical will ooze out and onto the weeds, and those weeds after 48 hours or so, they will be simply killed. So, they will not revive. In the meantime, your crop revives and then crop grows. Flow pattern according to GI range and previous flow. Actually, this is a system which has been created because several images in the process of movement, since it is an online system. You need to understand this part, that since it is an online system, we have to take several images, and then we have to identify the images accordingly, and then on the basis of that, the green index have to be understood and to be taken into consideration for application part. So, this is one flow pattern which has been given as a representative to you, and this you can understand. Those who have the idea about these image processing, they will be only able to understand this, but then what we are saying, that what we have in the different images which we get here, spray decisions. Now, depending upon, you can see here that see Q1 talks of the spray decision in the previous or the third image analysis, because images have been taken over several images, and what we are doing, what image was there, and by the time it has moved, whether we have been in a position to identify that image and taking the intensity or not, because ultimately on the basis of this itself, we are in a position to decide what is the amount of chemical has to be given. Similarly, the spray, say Q2 talks of the spray decision in the second image, and then Q3 talks in the last image, and fourth is the spray in the present image analysis. So, this is how and 1 and 0 is talking of, we represent spray or no spray. So, we are talking of this spray or no spray depending upon the value of the green index that we have here. So, you can see this. So, depending on the GI range that we have set for application, we are in a position to apply the chemical or apply the the herbicide through the you can say the rollers. So, this talks of the pattern here. Well, final working window. This is again until unless you have seen the arrangement for image processing, you may not appreciate this part, but then since we have done this and we want to show you how we have done, it is worth informing you. See here the application rate liter per hectare. This is the application rate what we are thinking. Then this is the roller width. What is the width of the roller? This is very important, because this width of the roller will depend on the row to row spacing of the crop. We have in tea gardens where the row is very big, even in the other orchards where citrus pomegranates are applied, the distances are very high. So, in those locations, then this roller width will be varying. Speed of operation, well, the speed of operation is another parameter which needs to be maintained and in order to control, because what will happen is, when you apply this, if you are moving at a very faster rate, then the amount of chemical which will ooze out onto the weeds will be lesser. At the same time, because of the higher speed of rotation and because of the centrifugal action of the rotation roller, lot of chemical will be thrown off, and although it may not go onto this, but onto the cover it will be thrown off and it will go waste. And that is why what we would like is that a proper speed should be taken. Now, so if you have taken a probability, then you put your OK in this. Now, he talks of the start here. Then similarly, now the camera 1, camera 2, camera 3, 4, 5, 6. So, all these camera depending upon the images that have been taken, it will start labeling and telling you what is the original image, the binary image. This will be labeled here. In each of the cases you will find this, and the amount of green index which will be found out accordingly, the chemical will be decided, the amount of chemical will be decided. So, you can see here that we are talking of the green index here, 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 in each of these from the cameras what we have taken, because you will find that these are not so much to the you can say that the chemicals, the weeds may not be so uniform all through the field. You may find in some of the rows it is very dense, in some of the rows it is not that much dense. So, it is very essential to identify the type of the weeds, of course, which we have not done in this. This could be said as a limitation of this particular exercise, that we have not been in position to exactly say the type of the weed. We have just found out that yes, it is a weed which can be removed or which should be killed. But at the same time, even the extent of infestation, because sometimes in the weeds you will find there may be more and different types of weeds entangled into that. So, many times when you are talking of a selective one, it will take only one group of weeds it will kill, not other groups, and therefore, it is very essential to have this information. And you can say that this is the one which we are still working on, this part of it, when you have 2-3 weeds entangled together or grown together. So, what will be the herbicide? Most of the time in that case we are talking of paraquat, or which is a non, you can say that it will kill the crop also. So, for that you will have to cover the cover these rollers, and you have to be very careful so that it does not even drip onto that. If you spray, the situation is very dangerous. So, we do not spray, but we would like to apply this and cover the rollers. In that case, then the roller size will be smaller. We have tested all these things. So, so far as if the control of weeds is concerned, yes, we are in a position to control these weeds to a greater extent by using this system. Well, digital image processing, well, this is how the images, you can see that here we have talked of all the details. This is the processed image which is shown over here, and the G intensity, B intensity, G intensity, R intensity, everything has been shown here, and the values also are shown in this particular figure. Just to tell you as that what do we do in the image processing, how it happens and all that, how do we get the values of this X, Y and RGB values which we get, what exactly we try to do in image processing. For that you need to learn image processing separately. Since we have learnt image processing separately and try to use here, that is why these details are being shown to you for your information, and well, you can use it wherever you want. Calculation of the green index, well, this has been talked that we will the green index is this total number of green pixels by the total pixels in the image, and the green index lies between 0 and 1, where 0 represents no weeds and 1 represents full of weeds of the same area, in the same area. And the amount of herbicide calculation is very simple. You can see here that the spray amount milliliter per hectare multiplied by the green index. So, this will talk with respect to, and then we can get the total spray amount, where A is the A is talking of the area of the field of view. This is the area of the field. So, once you know the area of the field, say for example, if you want milliliter here, so amount in milliliter per hectare, then the green index which is talking of what should be, and then the area. So, this will come, these two will cancel, and ultimately you will get SA. So, it is a very simple way of finding out the herbicide amount and calculation of green index. Now, why we are showing now here, we talked of all these things, and now I am showing the calculation. This is what is there in the software which we have developed. Well, field, now we would like to show you that this is the operation of this in the field here. You can have a look at how the whole system, this is the camera which is inside covered, then you can see the tank which is there, then the control system unit, and these are the various pipes which are connected, and you can see that these are the rollers, these are the rollers, these are the rollers here, the tube is coming on to this, then these are perforated tubes onto the rollers. You can see here field performance evaluation, yeah, you can have a look at this. You can see each and every aspect of this. This has been tested, and still further testing of this is going on under the field conditions, and we hope to bring this unit into the market depending upon the acceptability with the farmers and the type of crop, etc. Well, I have already told you that how do we measure the weed intensity. I have talked of the quadrant long back, so you can have a quadrant, and before and after you can simply measure before and after. See, if this is the situation here and this is the situation here, depending upon what you get, you see here what we have got here, what we have got here itself. The weed intensity before the application and then after the application, in two situations here, and after 48 hours this is the color of this, because we have used the chemical. So, that chemical will virtually burn this, and well, it will die, and then by the time another 3 weeks will be required for these to get up, and that is why we say that we are controlling, and by the time our chemical has I mean our plant has grown a lot and vigor and all that strength, it has got enough strength as compared to the weed. And we have seen that this system, about 40 to 45% of the chemical we are in a position to save, and that way you can imagine that how much of chemical can be saved. So, this is one system, advanced system, which has been applied for chemical control of weeds. If you have any questions, we will answer that later. Thank you for this. Thank you.